Hello, first graders. It's Mrs. Ryder here, and today I'm going to teach you about exploring air. It's one of our science units, so let's get started. What can air do? Air can move things from place to place. So if you are looking at this first picture, it's a clothing line, and you hang up the clothes to dry when they're wet. You can tell in the picture that the clothes are moving and the air is pushing them. We can't actually see the air, it's invisible, but we can see by the picture that the clothes are moving. So the air is pushing the clothes in one direction. The clothes aren't going in two different directions, they're going in one direction. So the air is moving the clothes. On the next picture, you can see the flag is moving and the air is pushing against it and making the flag move in one direction. And sometimes the air will change directions. And then last picture, the bag is flying in the air. Can bags fly? No, the air is pushing against the bag, making the bag go in the sky. Air can fill up plastic bags or balloons. So if you have a balloon and you fill it up and you blow on it and then you tie it, but if you were trying to tie it and then let go, then all the air will come out of the balloon. So if you have a balloon at home, you can try blowing up the balloon and then letting the air all out. Also, you put things that you also put air into are like swimming pools, inflatable ones, and you breathe into it and you blow it up. That is air being pushed in. So when a bag or balloon goes flat, the air goes out. So if I were to push this, the air would go out of the bag and then it'd be flat. You can feel the air blow through the straw onto the back of your hand. So if you take a straw and blow on it, the air will go through the straw and then it will hit your hand. Air takes up space and it's all around us. So there's air everywhere, but it's invisible. That means we cannot see it with our eye. How does a parachute use air? So this is a parachute and it helps people get down from the sky, or some people might just do it for fun. They have it on usually their backpack. They have a backpack on them and then they hit a button and then the parachute goes up. Why can't they just fall from the sky without a parachute? Because it slows them down so they don't just come flying through the sky. So the parachute slows them down. The air, this is the parachute, and the air is pushing up, making the parachute come down a little slower. So if you have a big parachute, you're gonna have a lot of air pushing at it. If you have a small one, you're not gonna have much air pushing down on it. The air underneath the parachute slows it down. What if you put more weight on the parachute? So this man, what if you put 4 or 5 people on this parachute? Would it go faster or slower? You're right, it would go faster. So if you put more weight on a parachute, it's gonna go down a lot faster. So when you're at home and you're gonna try to make your own parachute, I want you to try to put coins or some different objects of weight. You can put toys, some small ones. You can put an egg in there. You can even do Cheerios or goldfish. Put it in a cup or tie it to the bottom of your parachute string and see if they land safely on the ground. So if you put more weight on a parachute, it will go faster down to the earth. Any objects move through the air, it is always slowed down by air resistance. So anything that's coming down from the sky, from the air, is always slowed down by air resistance. So when the air is pushing up against a parachute, that's called air resistance. All right, we are going to be talking about when air is pushed into a smaller space. So these are called syringes, and you see these at the doctor's office when they give you a little shot in the arm. They put the medicine in the syringe and then they give you a little shot. So we're going to be using syringes, and then also this is a bike pump. They kind of look kind of similar. Air can be pushed out of a tube with a plunger. So if you take the plunger out of the syringe, you can get some air in the syringe and then push it. So then the air will be pushed out of the syringe. In this picture, we have connected two syringes. So the air cannot get out of these two syringes. We have air in this one and air in this one. So this person is going to push and pull. So we need two people here. They're going to push and pull the air between these two. We're right here. Pushing and pulling makes the air move from one syringe to another. So the air is going to go from this syringe through this tube and go over here. And this is going to create pressure. So if you're both on both ends of the syringe and you're both pushing at it, it's going to create pressure. So it's going to be really hard to push that syringe in because someone else is pushing too. And if the other person isn't pushing, then you push, it's going to go to their syringe. When all the air is pushed into one syringe, we say it's compressed. And we cannot put any more air in here. There's no more air coming in and out unless you take the plunger and take that totally out. So no new air can get in and no air can get out. Same with the bike pump. You're pumping air into the tire. So in here is filled with air and then you're pumping it into the tire. So it's kind of like the syringes. So you pump, 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 you create that pressure and then it goes into the bike. Balloon rockets. So this is called a balloon rocket. The first one has a Ziploc bag, and then this one uses straw and tape. So they're two different kinds of balloon rockets, but we're going to be talking about them. How can compressed air be used to make a balloon rocket? So earlier I talked about balloons, and if you put a bunch of air, you blow in a balloon, and it blows up really big, what happens if I let go and untie the bottom of the balloon? Yeah, it's going to go flying. So if you put it on a string, the balloon will go flying on the string. So you have to put it on a string or a fishing line and then use a straw so it can move down the line. So balloon rockets are kind of fun to make. The air inside the balloon is compressed by the balloon. So the air inside is compressed by the balloon. The balloon is holding all this air in. It's in there tight. It's compressed. It has all the air particles. This creates pressure to push the balloon forward. The more air you put into the balloon, the farther the rocket will travel. So there's pressure inside, and when you push the balloon forward, when you untie it, it's going to push forward because all the air pressure. Do you think the Ziploc bag balloon rocket will work? Which one do you think will work better, the Ziploc bag one or the one without the Ziploc bag? I want you to try it by yourself at home and let me know how it goes. I'm excited. So these are called balloon rockets, and we use the word compressed and pressure. So the air has pressure to move the balloon forward. Pressure moves the balloon forward. All right, I have some fun activities for you to try at home. I talked to you about the parachute. Some different ideas you can use with the parachute. You can use a paper towel. You can use a coffee filter. You can use a plastic bag, napkin. Some other ideas, you could use anything that will fold, like a napkin, paper towel, paper bag, a coffee filter, something that's curved and it'll fall down. And then also use string, and then you can put cup or a paper clip at the bottom of it. So I'm excited to see your parachutes at home, and then also you can create your own balloon rocket. You would need a balloon. I don't have a balloon at my house, so it's okay. You do not have to do these activities, but a balloon and a straw and some type of string or fishing line and some tape. And then this is called a wind vane, and this helps us tell the direction of the wind. So you can make a wind vane at home. I hope you learned a lot about balloon rockets and parachutes and wind vanes and exploring air. Really quick, I want to show you that air can move from place to place, and it takes up space and it's all around us. Thanks for watching, first graders.